How's it, grade 11s? Today we're going on to rate conversion. In other words, converting between different interests. So we have a read here, they say, we have seen that the more often interest is added to the original capital amount, the greater its growth. It follows, for example, that 10.5% compounded daily will yield a greater effective return than 10.5% per annum compounded monthly, since the rate is the same and interest is added more often. So with this daily rate, you're adding interest more often than you are if it was a monthly rate. Okay. However, it is not straightforward to compare different nominal rates with different compounding periods. Which yields a greater return, 10.5% per annum compounded daily or 10.55% compounded monthly? Even though 10.5 is the lower rate, it is compounded more frequently. So this 10.5 is compounded daily compared to this 10.55, which is compounded monthly. Now remember that these are your nominal rates because they're given as a per annum rate, compounded daily. And this 10.55 per annum compounded monthly. So those are nominal. Okay, and you remember the difference between nominal and effective. Nominal is your per annum rate. Your effective rate is the actual interest that is doing the work on your money. And you'll see now with examples. Okay. In general, to compare different nominal rates, we first need to convert them into their corresponding effective annual interest rates. In this way, we can compare rates of the same type. Okay, so we just got a couple of formulas here. So for a corresponding effective and nominal interest rate pair, the following two formulae give the same result. So we got the compound interest, and then this one is what you learned in the previous lesson, changing your compound period and your interest. Okay, so therefore we get this formula over here. Now, instead of using this one, I want you guys to rather use this one that I'm going to show you. It's exactly the same formula. It's just written differently. Okay. So instead of using this one, I would rather you guys use this where it says 1 plus I effective. So your effective interest rate is equal to 1 plus I nom, your nominal rate, over m to the power of m. Okay, so instead of using this one the way it's written, I would rather you use this one here. Okay, it's exactly the same formula, just written differently. Okay, then this formula is used to convert nominal rates into effective rates. So you see we've got our effective interest rate and our nominal. Remember, the nominal is your per annum rate. The effective one is the one that does the work on the money. Okay, into effective rates and vice versa. In order to convert a nominal rate of one type into another type, so converting one nominal into another one, this formula can be extended to this. So for this one, all we're going to be doing is we're going to be using this part here. Okay, and I'll rewrite that out for you over here. So it's saying 1 plus im. Now remember, this is not to the power of m, it's just giving the compound period, over m to the power of m equals 1 plus ik. Likewise, that's not to the power of k, over k, this is to the power of k. And that's the one that we're going to be using to change from one nominal to the next. Okay, now grade 11s, unfortunately these two formulae are not given on the formula sheet. You need to know them off by heart. And this kind of a question with this formula here pops up a lot. Okay, so just remember this formula here. Okay, so let's have a look. See, we've got example 1. It says here, consider the question posed in the notes. Which yields a greater return, 10.5% per annum compounded daily or 10.55% per annum compounded monthly? Okay, so for this question, what I'm going to do is I'm going to convert both of these nominal rates into a into an annual rate. So you can see here it's compounded daily. So I'm going to convert this compound daily into an annual one, and then this compounded monthly into an annual one. And once I've converted them both into an annual rate, I can therefore compare them, okay? As it stands, we can't compare them because one is daily and the other is monthly, okay? So from the formula that we learned just now, so this is example 1. Right, so from the formula that we learned just now, I'm going to be using this formula here where we convert one nominal into another. Okay, and I know I'm going to be doing that nominal to nominal because they've given it to me as a per annum, okay? Right, so I'm going to be working with, this one here is going to be my yearly one, so I'm going to make M equal to 1. Why? Because that's per year. Then this K is going to be equal to, if we look at the first one, they told us that it was compounded daily, okay? So that is 365. All right, so this IK, which is our I365, that is going to be equal to, they told us it was 10.5%, okay? I'm going to get rid of that percent. So we've got here now that I365 is equal to 10.5 over 100. Just like normal, guys, how you get rid of your percent. I'm just going to simplify that, 10.5 over 100. And we get 21 over 200. So we know that our I365 is equal to 21 over 200. Okay, and that is our daily interest rate. Okay, and we know what our M is. I'm going to substitute all of this into the formula here, and we get 1 plus I1, because M is 1, over 1 to the power of 1. Why? Because M is 1, equals 1 plus, now our K is 365 over 365 to the power of 365, because our K is 365. Start substituting these values in, and we get 1 plus I1 over 1 to the power of 1 equals 1 plus, our I365 is 21 over 200, but that is all over 365 to the power of 365. Okay, guys, so we've just got a bit of calculator work to do here. Before I do that, this is just to the power of 1, so this becomes 1 plus I1. Divided by 1 is just I1, okay? So let's work out what this is over here. So we've got 1 plus 2 fractions, 21 over 200, all over 365, and that's to the power of 365. Okay, and I'm just going to write that whole number down. So we've got this is equal to 1,110693,839. Subtract 1 from it, and we get I1 is equal to 0,110693,839. Okay. And now what I'm going to do is I'm going to convert that into a percent. And we do that by multiplying by 100. So I'm going to subtract 1 from this and then multiply it by 100. Then what I'm going to do is I'm going to round this off to 3 decimal places. So we get I1 is equal to 11,069% per annum. Okay. It's not compounded any period, but per annum. Why? Because I converted it to that per annum rate. Okay, so that's it for the 10.5%. Now let's have a look at the next one, which is 10.55 compounded monthly. Okay, so here we've got IK is equal to 10.55%. And this is compounded monthly. So my M is still going to be equal to 1 because I want to convert it into per annum rate. And now the K is going to be 12 because it's to a monthly rate. So I12 would be equal to 10.55 over 100 because it's the same as this. We want to get rid of that percent. I'm just going to simplify that. So 10.55 over 100, and we get I12 is equal to 211 over 2000. Okay, now I'm going to use this formula over here. 1 plus I1 over 1 equals 1 plus I, our K is 12, over 12 to the power of 12. Okay, let's substitute stuff in here. This is to the power of 1, sorry. Let's substitute some stuff in here, and we get 1 plus I1 over 1 to the power of 1 equals 1 plus I12 is this 211 over 2000, all over 12 to the power of 12. Okay, with this thing over here, to the power of 1, so it's just 1 plus I1, divided by 1 is just I1. Work out this on the calculator. And we've got 211 over 2000, all over 12 to the power of 12. And we get 1.11075386.2. I'm going to subtract 1 from that, and we get I1 is equal to 0.11075386.2. To convert it into a percent, we multiply by 100. So subtract 1 here, multiply by 100, and round that off to 3 decimal places, and we get I1 is equal to 11.075% per annum. Okay, now that we have them both in a per annum rate, so here's the one, and that was for 10.5%, and the other one is this one here, and that was for the 10.55. Okay, so which one is the bigger one? Well, it's definitely this one here. So you would have thought that because this is compounded more often, I mean it's compounded daily compared to monthly, that this one would give you the better rate, but not necessarily. So you can see here, if we converted them to a per annum rate, this one is definitely giving you the better interest rate. So therefore 10.55% per annum compounded monthly is the better option. Okay, right, going on to the second example. Okay, so the second example here is saying a man is charged 8.5% per annum effective on his home loan. Determine the rate compounded monthly that the bank originally quoted him. So what we got here is an effective rate. What we want to find is the nominal rate, okay? And that is going to be this formula here, okay? So they've given us the effective. We want to find the nominal, okay? So get started on this. Example 2. Okay, so the formula I'm going to be using is this 1 plus I effective equals 1 plus I nominal over m to the power of m, okay? And remember, guys, they've given us the effective rate of 8.5%, okay? I'm going to convert that to over 100, so we get here 1 plus 8.5 over 100 is equal to 1 plus I nominal, because that's what we're going to find. Now, your M. They told us here that it is compounded monthly. So our M is going to be 12, because there are 12 months in a year. Okay, so first things first, let's work out what that is over there. So we've got 1 plus 8.5 over 100. Then, guys, I'm going to take the 12th root because I need to get rid of that. Okay, so the 12th root of our answer, and we get that number there. So we get 1,006 821 493 equals 1 plus I nom over 12. Okay. Now, again, guys, I'm just going to miss some steps, but I will show you on the calculator what I'm doing. First thing I'm going to do is I'm going to subtract 1 by taking to the other side, and we get that. Then I'm going to multiply up by 12, and we get that. Okay, so we get I nom, or the nominal interest rate, is equal to 0,08185792039. Okay. We want to get that into a percent, so we multiply by 100. So I take this answer, multiply it by 100. And then what I'm going to do is just round it off to 2 decimal places. So we get I nom is equal to 8,19% per annum. Okay. And what we've done is we've converted the effective into the nominal rate. All right. Last example, guys. So what we have to do here is we have to calculate I4 if I2 is equal to 0.222. So that is this formula here, where we're converting one nominal rate into another nominal rate. Okay. So we have that I2 is equal to, they gave it to us as 0.222. And we want to find I4. Okay. So that means that this is the one I want to find. So M is equal to 4 and K is equal to 2. All right. So the formula that we're going to be using is 1 plus IM over M to the power of M equals 1 plus IK over K to the power of K. All right, so we just substitute things in now. We get 1 plus M is 4, I4 over 4 to the power of 4 equals 1 plus I2 over 2 to the power of 2. 1 plus I4 over 4 to the power of 4 equals 1 plus, now our I2 is that, 0,222 over 2 to the power of 2. Okay, guys, so I'm going to do things on the calculator here now again, and skipping some steps that I don't have to write down, but just watch what I do. I'm going to be doing this side first. So we've got 1 plus 0.222 over 2 to the power of 2. That's that. Equals. Then I'm going to take the fourth root because I need to get rid of that to the power of 4. So to the fourth root of that answer. And we are left with 1 plus I4 over 4 equals 1,054,039,847. I'm then going to subtract 1 from that. Okay, so that's gone. Then I'm going to multiply by 4 to get I4 on its own. So we get I4 equals 0, and what I'm going to do is I'm going to round this off to 3 decimal places. 216, just because this one was 3 decimals. And there you go, I've converted I2 to I4. All right, grade 11s, what I would like you to do is exercise 12.6, number 1, 2, 4, 6, 8, and 11. Thanks, guys, and enjoy.